Very good morning, guys. So today we are looking at the fourth video in our series Mastering Search Processing Language, where we are trying to cover most of the less used command or relatively less used command. However, these commands are quite impactful. So we'll be looking at all those. And before I get started, we had an opportunity to discuss about transforming commands and grouping and correlation commands, and we have also talked about time zone related issues. We have looked on to the cases of time chart command as well, and the link for those particular videos were there in the description. So before I get started, you may also want to have a look at the description, uh, as there is some kind of the reference material if you are trying to master the search processing language is available for the download for the subscribers. So without any delay, we will get started. So we will be getting started with our demonstration for the IP location as a command. So let me get into my source type, access combined. So as the name of the command suggests, IP location, if we are trying to retrieve some other details of the IP address, for example, city and country, this kind of the command will definitely add some kind of the value to our results. IP location. So this time I will be using IP location, and I do know the field which is existing client IP. So let me run in the verbose mode because I would like to demonstrate something before we get started. So for example, if we are using IP location as a command, you can see that there are some of the fields which are getting generated. For example, city is one of the field and country is also one of the field. And if you're using this particular command, we can try to represent our results, or maybe transform the results with the help of city and country fields. So for example, stats count by country. So let's try to have a look at the result. So for example, we can see that, with the help of IP location as a command, we are trying to transform the result or split the result by country as a field. And in the visualization, I think this point in time, it makes sense if we are using the pie chart to represent our data. So this is how we can use IP location. So for example, in the environment which I am working, we do have guard duty logs, AWS guard duty logs fed into the Splunk environment, and we also have AWS CloudTrail logs fed into our environment. So talking about the guard duty logs, it does give you the details. So for example, if any external IPs are trying to brute force your instances, so guard duty does have the very detailed view about that particular IP address. That IP address belongs to which organization and resides in which city, which country. But however, if and you also have this kind of the data available in some of the threat intel feeds, which your environment might be getting daily. But however, if you are not having those kind of the details, please try to leverage this functionality IP by this particular command, IP location. So let's move on to some other stuff. So for example, we have an opportunity to look at the so we did use transforming command stats, and so subsequently we are trying to look at the geostats as a transforming command as well. If we want to represent the data in a similar way, I mean, using the cluster maps, we may want to use geostats as a transforming command. So the syntax remains same by country. So I think I need to change the formatting as well. So for example, here I will try to use a cluster map, and let's try to have a look at the representation if we are using geostats as a command. So for example, you can see that we are trying to represent the same results with the help of geostats as in command. So now we will be moving on to the other command, which is nothing but xyseries. I found this particular command extremely useful in the way we are representing the data. And let's try to have a look, how does it basically adds effect to the representation. Okay, so let's move on to the xy series as a command. So probably we'll be using the same source type. So for example, stats count by product ID and item ID. So this is a simple command. We are using the transforming commands. So let me go to the statistics. So for example, we have tabulated the results by using the stats as in command. We will be looking at all the rows which does have the combination of the product ID and the item IDs, and we will be looking at all those combinations in our results. So for example, if we were to represent the same data with the help of the XY series, we can represent the data in the two dimensions. So for example, let's say we are splitting the result or representing the data of the product IDs on the x-axis and item ID on the y-axis. So XY series, and I would say product ID and item ID, and we are trying to represent the count. So count as a function, and let's just for the faster results. So I think you can see that, we are trying to represent the same data in the two dimensions, and so sometimes this particular xy series command becomes extremely helpful if we are trying to represent data across two axis. So for you can see that product ID is being represented in all the rows and all the item IDs are being represented in the columns. So I'm trying to have a single demonstration for each command, and so hopefully it might help in your day-to-day task. So for example, let us move on to the next command, which is nothing but the add totals. So for example, just give me a stats count by product ID and item ID. So for example, just give me a second. So I will be populating the results in the previous case. So we can see the respective count for the product ID and the item ID combination. So I will be using the chart command. I think in the previous video we had an opportunity to talk about the chart command if we really want to represent the data in a little bit different way as compared to the stats command. So for example, chart count by, and we will be using two fields when we are using chart command. So product ID, product ID, and item ID. So this is the default result which we will be getting if we are using the chart count. So for this representation, if we really want to add the grand totals, so for example, if we really want to add the totals for this particular product ID, and we will be cumulatively adding the count for all the respective item IDs. So we can use add totals as a command. So hopefully we will be getting the results. So if you can see at the very right hand side, we are getting the respective total for one particular product IDs, and we are adding cumulatively all the item IDs which are falling under this particular product ID. And similarly, if we really want to calculate the grand totals for all the columns, we can make the use of one more command, which is nothing but addcoltotals. So in our initial result, we are not seeing the cumulative totals for the respective columns as of now. So let's try to run this particular command now. So for example, as of now, you can see that we do have one more row, which is basically representing the cumulative count for one particular column. In our case, nothing but the item ID. So let us move on to the next command, which is nothing but the bin command. So we will be using bin command to bifurcate the events into the various buckets, and I will demonstrate to better comprehend what I am saying as of now. So let us get started with that. So let's say we are only interested in the action purchase, and stats count as purchases. Stats count as purchases by let's say respective categories. Okay, and we will also try to create different buckets because we will try to classify the events in the different buckets based on some of the arguments which we will be passing. So for example, let's use bin command. And we would like to use the criteria for that purchases, and we will be passing an argument, let's say 500. So basically at the threshold of 0 to 500 there will be one particular bucket, and if we are looking at the count of the events beyond 500, there will be this so from from 500 to the 1000 threshold, there will be a second bucket which will be getting created. And so we will move on. So we are trying to segregate the events into the different buckets. So for example, now stats list category ID by purchases. And we would also like to sort the result. So for example, you can see, so for example, we can see the purchases, the number of the purchases for each category. So for example, for the category sports, the purchases must have fallen between the range of 0 to 500, and therefore sports has fallen into the this particular category. And we can see for the second category or the second bucket, so for the categories like shooter and simulation, uh, the number of the purchases should be falling somewhere between 500 to 1000. So we are trying to categorize the number of the purchases into the different buckets as per their count. So hopefully it makes sense. I found this particular command extremely useful if you're trying to uh, distribute the events as per the number of the count or the number of the purchases. In our case, we will be moving on to the subsequent command, which is nothing but the erex command. So let us get started with that. I will be using the different source type for the demonstration of the erex command. So let me find out the source type. So before that, so erex command is operating on the something similar as compared to the rex command. If you are somebody, and if you are someone who is not very proficient with respect to the regular expressions, this particular command will definitely be helpful to give you an idea how you can structure the regular expression if you're trying to extract something from your raw data. So I just ran this particular search job. I just wanted to show you the raw data before I move on further. So for example, you can see the raw data. So if you are able to see the raw data, so for example, you can see a DHCP request, you can see DHCP acknowledge, you can see bound. So let us say that we are interested in extracting this particular value from our raw data. However, we are not very proficient with respect to the regular expressions, so we can use erex as a command, which is a very good functionality we can make a use of. So for example, erex type of request examples, let's say DHCP ACK, DHCP ACK. So if I try to execute this particular command, and if I try to navigate my pointer to the job, inspect job, so if I click on this, you can see that there is a respective regular expression which has automatically been created by the Splunk. So for example, in our case, we are trying to capture the values which we are interested in our case, which is nothing but a DHCP acknowledge request and DHCP request into the field which we are naming it as a type of request. So we have automatically retrieved the regular expression to extract this particular value from our raw data. So this particular command might be very useful if you are getting started with the regular expressions, and if you really want to move on from the beginner to the intermediate, and henceforth maybe on to the expert level or advanced level. So this particular command might you want to leverage. And I will be moving on to the subsequent command, which is nothing but coalesce command. So if you are somebody who is dealing with the content management, this particular command might be very helpful, because you are trying to correlate the results from the multiple indexes, or you might be leveraging the multiple data models. And if you're somebody who's dealing with the content management and structuring the correlation queries, you often see the use of the coalesce as a command. And I will try to demonstrate something with my test data. And so, I will be looking at the different source type. Okay, so just give me a second. So this is the test file basically. Let me try to execute this particular command in the verbose mode, because I would like to take you all through the respective fields. So for example, let's say in our raw data, the value is getting captured into the multiple fields. So in our case, let's say for one particular product ID, we do have the correlation. So we are getting the value which is getting captured into the different fields. So for example, correlation ID is one of the field, transaction ID is also one of the field, and tran ID is also one of the field. So we are not getting the values in all the fields, however in one of the fields. And we would like to correlate the results into the let's say the master field, and we will be creating that particular field. So for example, eval transaction. So we will be creating a master field which will basically include the results for all the other three fields, regardless of the value is getting captured in which of the fields. So anyways, I will try to demonstrate that. So basically what we are trying to do is, so we will be creating a master field which will be capturing the values which is getting captured in any of the fields. For example, correlation ID, tran ID, and transaction ID. So let's call the master field as transaction ID. Transaction ID. So tran ID, transaction ID, tran ID, transaction ID, and correlation ID. So this particular command will be extremely helpful. For example, if you are making a use of two different indexes, and for example, if your client IP or the source IP is getting captured in the two different fields because you are making the use of the two different indexes or two different source types. However, you want to capture the results in one of the master field which you may want to refer, right? So transaction. So let me try to execute this particular result. So I will be moving on to this particular master field, and you can see that all the values are being captured into this particular master field. So this particular command you may want to use if you really want to correlate the data from the multiple indexes or multiple source types. I think you often see this kind of command named coalesce in all the queries, all the correlation queries, and the queries which are just behind the dashboard. So I thought maybe I will be including this particular command. So now I will be moving on to the last command in our demonstration, which is nothing but the tstats. Obviously tstats is one of the commands you will be finding in every correlation query, and every query or whatever the dashboard you are able to see. I think because tstats basically help us in optimizing the searches, and you will definitely see tstats as a command in most of the correlation queries and the queries behind the dashboards, where you are trying to leverage the data models as well, right? So I will be taking you through the one or two demonstration for the t-stats, but however I will demonstrate in detail t-stats when I do have the Splunk enterprise security ready in my lab environment, where I can really make a use of some of the data models, like pre-configured data models like authentication, network traffic, or web data models. But however, I will definitely give you the glimpse in this particular video. So for example, tstats, you may also want to compare the results of the tstats with respect to your transforming command, and you will be surprised. The tstats give you the results all extremely fast as compared to your transforming commands. So where index is equal to star and group by index. So I'm just running this particular command. So we are trying to have a look at the count, the count of the events with respect to all the indexes. So obviously in your production environment, the data might be very, very huge. And so for example, if I go to I inspect job, you can see that it takes 0.359 seconds to execute this particular job. And if we try to execute the same result with the help of the transforming command, there might be a difference. So let's try to do that. I have just paused the video in between, and so I will be again looking at the job inspector, and I'm just trying to find out if I'm using the normal transforming command, how much time does it take. So for example, you can see when we ran the tstats as a command, it almost takes point lesser than that of zero point 0.4 seconds. However, if I'm trying to run the transforming commands, it is taking as 23 seconds. So the results, you can say, you can see the difference. You yourself see the difference between the execution of these particular commands, right? So let's move on to the one more demonstration, and then we will be ending our video. So for the tstats, I am just trying to explore one of the data models. I don't have the pre-configured data models like in the Splunk enterprise security environment, but some of the internal data models. So just give me a second. Data model, internal audit logs. I'm just trying to retrieve so we are trying to have a look at some of the schemas for this particular data model to make use of this particular data model to construct one of the query. So I will be wanting the list. So I was just trying to have a look and try to look at the schema of this particular data model. So for example, you can see, the data audit, and so we will be using the field name as an action, and we can also see the, the owner is nothing but the audit, and display name as well as audit. So let's try to construct one of the query using this particular field. So I will be using tstats. So tstats, sorry, tstats count from data model internal audit, internal audit logs by audit. So audit is nothing but the data set name dot action, which is nothing but the field name. So in all the various data models, you always see, the data set name dot the field name. For example, if you're talking about network traffic as a data model, all traffic dot action. So all traffic is nothing but the data set name. So in the network traffic data model, you might see some of the data sets like allowed traffic, block traffic, and all traffic. So these are the data sets names under the data models. So we are using this example. So let me see whether it gives any result to us. So for example, we are trying to make a use of, this particular data model, and we are leveraging tstats as a command. So we'll definitely explore some of the use cases for tstats in the subsequent videos. Once I do have once I will have, Splunk Enterprise Security Environment ready to explore definitely the most leveraged data models, for example, network traffic, web, as well as authentication. So that's it for this particular video, and please do let me know, whether you find this particular video useful or not. Please do like, comment, subscribe, and share. Thank you.